This video, we're going to talk about composition of functions. In this section, students will combine functions using algebraic operations, create a new function by composition of functions, evaluate composite functions, and find the domain of a composite function. So to begin, we're going to talk about combining functions. For two functions, f of x and g of x, with real number outputs, we define new functions f plus g, f minus g, f times g, and f divided by g by the relations. So when they tell us to do f plus g, we write it as f plus g of x, and that equals the function f of x, plus the function g of x. When we subtract two functions, so if we're subtracting f minus g, we do f minus g of x equals f of x minus g of x. When we're multiplying two functions, f times g, we would multiply f of g of x, and that equals the function f of x times the function g of x. And last, when we're dividing two functions, f divided by g, we write f over g of x, and we calculate it by dividing f of x by g of x, where g of x can't equal 0 because then it would be undefined. So let's try one. So we want to find and simplify the functions g plus f of x, g minus f of x, f times g of x, and f over g of x, given f of x equals, and this should say x squared plus 2x plus, I'm sorry, let me repeat that, f of x equals x squared plus 2x, and g of x equals 6 minus x squared. Okay, so we're going to basically do four problems. The first problem is g plus f of x. So what we want to do is we're going to take g of x and we're going to add f of x. And we can see that g of x is 6 minus x squared, and f of x is f of x equals x squared plus 2x. So we're going to substitute those into g of x plus f of x. So g of x is really 6 minus x squared. Notice I put that in parentheses, okay, because I'm substituting it in, plus f of x. F of x is really x squared plus 2x. So now look at what we have. We have 6 minus x squared. There's nothing to multiply that by, so we can get rid of the parentheses, plus, but we can get rid of the parentheses here, x squared plus 2x. And then we're just going to add together. So are there any like terms? And right off, I see in the center I have negative x squared plus 2x squared, which I know will cancel. And then that leaves 6 plus 2x, which you can also write as 2x plus 6. Okay, so next we're going to do g minus f of x. And that equals g of x minus f of x. So first, we're going to replace g of x with 6 minus x squared minus f of x, which we are going to replace with x squared plus 2x. Now, what we need to remember here is we are subtracting the entire parentheses, the second parentheses. We're subtracting all of this. So we are subtracting x squared and we're subtracting 2x. So you may want to change this to plus a negative and make the whole parenthesis negative. Had any of the terms in the second parenthesis been negative, we would change it to positive in that case. So now we have 6 minus x squared plus negative x squared plus negative 2x or minus 2x. So now we want to add any like terms, and we have negative x squared and negative x squared are like terms, and that is going to give us negative 2x squared. Then we'll bring down this negative 2x, and we'll bring down this 6, which happens to be a plus 6, and you can't go any farther than that. Alright, next we are going to do f times g of x. So we will need to find f of x, and we'll need to take g of x, and we will need to multiply those two together. So let's just remind ourselves what f of x and g of x is. So f of x is x squared plus 2x, and g of x is 6 minus x squared. So f of x, I'm going to write x squared plus 2x, and g of x, I'm going to write 6 minus x squared. Alright, and so now we're just multiplying these two together. So we are multiplying, I'm just going to write it out, x squared plus 2x times 6 minus x squared. Okay, so you're multiplying a binomial times a binomial, so 2 terms times 2 terms. So what I like to do is I like to distribute each term in the first parentheses to each term in the second parentheses, and then add any like terms. Some of you may know of this as FOIL method. So if I do the first, x squared times 6, I'll get 6x squared. Then I'll distribute the x squared to the negative x squared, and that gives me negative x to the 4th. You remember, when you multiply variables with exponents, if they have like bases, you add the exponents. That's the law, one of the laws of exponents. Alright, now that I have exhausted the x squared, I've multiplied the x squared times everything over here, times the 6 and times the negative x squared. Now I'm going to pick up with the 2x, and I'm going to distribute it to both terms. So I'm going to distribute it first to the 6. 2x times 6 is 12x, and then I'm going to distribute it to the negative x, and that gives me negative 2x squared. And then I'm just going to rearrange it so it goes in order of degree. Degree would be the exponent, so the highest exponent would be x to the 4th. The next highest exponent, oops, did you guys see my mistake? When I multiplied this 2x times the x squared, that's not equal to negative 2x squared. What should it be equal to? 2x to the 3rd. 2x to the 3rd. So that was my fault. I apologize. So now rearranging, negative x to the 4th would come first, followed by negative 2x to the 3rd, followed by 6x squared, and last would be plus 12x. And you can't go any farther than that because they are not like terms. And last, we have f over g of x. And for this one, we're going to take f of x, and we're going to divide it by g of x. So where g of x can't equal 0. So f of x was x squared plus 2x over g of x, which was 6 minus x squared. And to see if you could reduce it at all, I mean, you can factor the top that factors into x times x plus 2 because x squared and 2x have a greatest common factor. But there are no greatest common factors on the bottom, and it's not difference of squares. So this is really as far as it can go. You can leave it like this or like that. All right. So your turn. Move this up a little. Oops. Your turn to try it. So you guys are going to take the f of x equals x minus 1 and the g of x equals x squared minus 1, and then you are going to add the two together, subtract the two together, multiply the two together, and divide the two together. And then when you unpause the video, we will go over the answers. Okay, so for the first one, we're going to add f of x plus g of x. So f of x is x minus 1 plus g of x. G of x is x squared minus 1. So if we have x minus 1 plus x squared minus 1, the like terms would be, oops, negative 1 and negative 1. So if we add negative 1 and negative 1 together, we get negative 2. So our final answer is x squared plus x minus 2. Okay. So now let's try f minus x, or I'm sorry, f of x minus g of x. So for that one, we have x minus 1 in parentheses minus x squared minus 1. So the minus becomes a plus a negative. So this is x minus 1 plus negative x squared, and then that becomes a positive 1. So that leaves negative x squared plus x, and then the negative 1 and the positive 1 cancels. So it just leaves x squared, negative x squared plus x. Alright, so next we're going to do f times g and f over g. So f times g of x is the same as saying f of x times g of x. So we have f of x, which is x minus 1, times g of x, which is x squared minus 1, and then we're going to just distribute. So x times x squared is x to the third. X times negative 1 is negative x. Negative 1 times x squared is negative x squared. And negative times a negative is a positive 1. So we get negative x squared. We get x to the third minus x squared minus x plus 1 if you put it in degree order. And last, we have f over g of x, which is the same as f of x over g of x. And f of x is x minus 1, and g of x is x squared minus 1. Now this one we can actually reduce. We can reduce this one. And the way we reduce a fraction is you need to write it as factors. So the top you can't factor x minus 1, but the bottom, hopefully you'll notice x squared minus 1, that is difference of squares. So it's the square of x and the square of 1. So it'd be x plus 1 times x minus 1. If this is not something that you remember, then go look up difference squares. You can look it up on Khan Academy. You can probably go back to chapter 1 of our textbook and look it up as well. Okay, so now that we have factored it as x plus 1 times x minus 1, we can cancel out the x minus 1 with the x minus 1. That leaves a 1 on top. So our final answer is 1 over x plus 1. And actually, g of x can't equal 0, so in that case, g of x squared minus 1 can't equal 0, so x squared can't equal 1, so x can't equal plus or minus 1. So x can't equal positive 1 or negative 1. So we're going to stop the video here and let you take a break before we pick up with our next portion where we will talk about composition of functions.